Hi class, we are on 3.2a lesson on page 44 of the lesson packet. So at this time, go ahead and take out your lesson notes, pause the video if you need to. And I will be collecting notes today, so it's really important that you write this down and are paying attention throughout the video. So the first one says, write some different ways that 12 can be written as a product of two positive factors. Then model each product. So first word that I need to kind of address here is that the product is just the answer to a multiplication question. Okay. So when this is asking us to write 12 as the product of two positive factors, I have to think about what two numbers can be multiplied together to equal 12. So the first one that I think of is 6 times 2. Another one that I think of is 3 times 4. Another one is actually just 12 times 1. So now we want to model all of these. So let me go ahead and scroll this down. So 6 times 2 is saying 6 groups of 2. So I'm going to draw 6 groups of 2 and then just outline that they're 1, 2, 3, 4, 5, 6. And these are, I'm just going to unshade for positive and shade for negative. For 3 times 4, I'm just going to draw 1, 2, 3, 4. That's one group. 1, 2, 3, 4. 2 groups. And then another 4. That's 3 groups. For 12, I still want to show 12 tiles, but I want to break them up so that it's just a group of 1. So that's 8. That's 12. So then I'm just going to show this is actually 12 groups of 1. So this next one says model 4x plus 12. When we model 4x, we actually have to draw out each individual x. We can't just draw out a rectangle and write 4x. We need to draw out 4 actual rectangles. And then for the 12 positives, I'm just going to draw 12 positive boxes. Write the different ways that 4x plus 12 can be written as a product of two positive factors and model each. So this is similar to the other one. I have to think about what can actually go into 4 and can go into 12. Or I should say 4x and can go into 12. So I think of the numbers 4 and 2. I know that 2 can go into both of those. But if I have 2, then that means I have 2 x's, and that means I also have to have 2 groups of 6. So another one could be 4 goes into 4 and 12. So this would mean that I have 4 x's, and then I also have 4 groups of 3. So typically, we're going to actually write it like 2 times 2x plus 6. It's important to understand that this up here and this up here, it's actually the same thing. So when I model this, it's 1, 2 x's, and then I'm going to do another 2 down here. And then I have 1, 2, 3, 4, 5, 6, and then another 6 right down here. For 4x plus 4 times 3, I'm actually going to write it as 4 times x plus 3. Because this is saying that I have 4 groups of x plus 3. So there's 1 group, there's 2 groups, there's 3 groups, and there's 4 groups. And I should probably label these as x's. Okay, next page. It says model 2x plus 2y. Write and model a different way that 2x plus 2y can be written as a product of two positive factors. So I have to think what number or what variable goes into both 2x and 2y. And I know that 2 goes into both of them. So I can actually factor out a 2. So it's 2 times x plus y. So how I would model this is just 2 groups of x plus y. So there's my x, there's my y, there's my x, there's my y, and there are my 2 groups. This is different from if we modeled it as 2x plus 2y, because if it were 2x plus 2y, doesn't really look like an X there. It would be the X's as a group and then the Y's as a group, rather than these are kind of two separate groups in this one. Okay, so this next one, number 5, says model 6x plus 12. Write the different ways that 6x plus 12 can be written as a product of two positive factors. So the first thing it asks me to do is just to model 6x plus 12. So I'm just going to go ahead and draw exactly that. 6x's, 3, 4, 5, 6, and then 12 positive ones. So there's my 6x plus 12. And then it also says write the different ways that 6x plus 12 can be written as a product of two positive factors. Well, if I were to factor out a number that went into both 6x and 12, I know that 3 goes into both of those. So 3 times 2x would equal 6x, and then plus a 4, because 3 times 4 would equal 12. So this would be 3 groups of 2x plus 4. Another number that goes into both 6 and 12 is actually 6, but I would have to multiply 6 times x and 6 times 2 to actually get it back to looking like 6x plus 12. Another one, I could actually just write 2x plus 2x plus 2x plus 2 times, or plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. I could write it all out like that too. Okay, so this is kind of leading us into something that we call the distributive property. And we're kind of working backwards here because we are given an expression and we want to factor something out. Factor means take a number out. We will also eventually be able to then distribute that 3 and multiply it times both of those. So we'll get to that later in the lesson. So now it says draw a model for the expressions and simplify each expression. Okay, well 3 times 2 is 3 groups of 2. So I have 1, 2, 3 groups of 2. And when I simplify 3 times 2, that just gets me 6 as my answer. This is saying that I have 3 groups of x plus 2. So I have to draw my, whoa, that's not an x. I have to draw my x plus 2, my x plus 2, and another x plus 2. And I have 1, 2, 3 groups of x plus 2. Now I also have to simplify. So I have 1, 2, 3 x, and then I have 6. So continuing on from page 2, we are now modeling -3 times 2 and simplifying. And some of you guys might actually be able to simplify this in your head right now, or actually we all should for module 2. A negative times a positive gives me a negative number, and 3 groups of 2 is going to be 6. So in the past, I had you guys draw that I have 1, 2, 1, 2, and then I have also the negatives right here. Okay, because if we're going to take away 3 groups of positive 2, I have to have something else left when I take that away. So then I had you guys actually cross out 1, 2, 3 groups. Now, if you just want to draw these 3 groups of -2, that is okay with me if you just draw 3 groups of -2. It just has to represent our answer correctly. Okay, so for number 9, this is actually saying that we need to take away 3 groups of a positive x plus 2, but this could also mean that we just have 3 negative groups of x plus 2. So I have x and -2, x and now -2, and then another x, and now -2. Because when we have a negative, we actually have to distribute that in to both of these. And it's okay if you don't understand this quite fully yet, because we're still learning what distribute means. But this would be 1, 2, 3. What's really important is I already made a mistake here. Since this is negative, I have to label this as a negative x, a negative x, and a negative x. And then I also have -2, -2, -2. So you could actually rewrite this as 3 times -x and then plus -2. That way we remember to actually draw everything correctly. Okay. So number 10 says, what does the number in front of the parentheses tell you about grouping? And the number in front of the parentheses, like in 8 and 9, it just tells you how many groups or the amount that are in the parentheses that we need to draw. So it tells you the, I'm going to say, it tells you how many groups that we have, or how many negative groups that we will have. Okay, so now model 3 groups of 2x plus 1. So I'm going to draw just one group first. I have x plus 1. That's a group. Now I have a second group of x plus 1. That's a group. And then a third group of x plus 1. That's a group. Now it also says simplify, which means that I need to actually write my answer. So I have 1, 2, 3, 4, 5, 6 x's. And then I have 1, 2, 3 1s. So that will be my answer. Another way that you might be seeing how to get this is I can distribute 3 times 2x plus 3 times 1. That's what we call the distributive property. All right, this next one says model 3 times 3x minus 2 and simplify. Change the expression to blank for easier modeling. All right, so when it's asking us to change an expression, when we have subtraction, it's basically asking us to rewrite this as addition. So this is 3 times 3x plus -2, because that's quite a bit easier to model now. So I have 1, 2, 3 x's, and then I have 1, 2 negatives. So this is one group, and I have to draw 3 of those. So 1, 2, 3, and again 2 negatives. So that's group 2, and then 1, 2, 3, and then 2 negatives. So that's group 3. It also asked me to simplify. So in total, if I were to count up all the x's, I have 9 x's total. And I have 1, 2, 3, 4, 5, 6 negative boxes. So I could write it like that, or I could also write 9x minus 6. Both of those are the same. Again, you could actually get this by distributing that 3 and multiplying 3 times 3x, which would get you that 9x, and 3 times -2, which should get you that -6 there. So I know this lesson is 5 pages. Now would be a good time to pause the video, give yourself a break, make sure you understood the first 3 pages, and then come back to it another 5 minutes if you need to. Okay, so coming back from a break, if you needed that break, then we are now going to be on number 13. We're going to model -3 times x plus 1. But remember, this usually says take away 3 groups of x plus 1. It also means that we have 3 negative groups of x plus 1. So you can model in whichever way is easier for you. I'm going to model the 3 negative groups of x plus 1. So if I had x plus 1, it would look like that, but I have to make these negative. That's a really important step. So I have to write -x, and then I have to shade this one in. So I have one group there, Now I have another negative x plus a negative 1, 2 groups, and then another negative x plus a negative 1, 3 groups. Now when I simplify, I have negative 3x plus negative 3. You could also write it as negative 3x minus 3. Either way is fine. And again, if we were to distribute, going back to the original problem of 3 groups, negative 3 groups of x plus 1, if I distribute that negative 3 times x plus that negative 3 times 1, that will give me the same exact answer here. Okay, we're going to go ahead and skip number 14 and get down to the distributive property of multiplication over addition. So this is what I've kind of been introducing you to throughout this lesson. The distributive property says that if I have a number, we're just going to say the number is a, and I'm multiplying it. Remember, whenever I have a number on the outside of the parentheses, it's saying that I'm multiplying. Multiplying it by 2 things that are being added or subtracted, then I can distribute and multiply a times b and then add it to a times c. So if I were to do an example here, let's say 3 times 2 plus 5. So my 3 is a. So this would be 3 times 2 plus 3 times 5. And then I could simplify from there. It would be 6 plus 15. 6 plus 15 will get me 21. So that would actually be my answer there. Okay, so this is called the distributive property when we have a number outside the parentheses with a group of something and we're distributed inside. Number 15 through 18 says rewrite the following using the distributive property. So I still to this day make these little rainbow things to help remind myself that I am going to multiply 6 times 4 and then also multiply 6 times 5. So that will get me 6 times 4 is 24. 6 times 5 is 30. Okay, it's actually not asking me to simplify here, so this is actually as far as I need to go. But if it were asking you to simplify, you would actually get that answer of 54. Okay, so same thing with 16. I'm going to use the distributive property. This is x times y plus x times z, and that's as far as I can go. I don't actually need to write that multiplication sign in between, so that's actually my answer there. For number 17, 7 groups of x plus 2, so I have 7 times x plus 7 times 2. Again, if it said simplify, you could simplify that 7 times 2 further, but we don't need to do this today. 9 times 3x plus 9 times 1. Right? So that is the distributive property there. And it helps us so that we don't always have to model this. Okay, this next page says use what you have learned to simplify each numeric expression 2 ways. That just means that these are including numbers now and not just variables. So the first one is done for you. 4 times 2 plus 3. So you could write it as 4 times 2 plus 4 plus 3. When you simplify, it's 8 plus 12 or 20. Because of PEMDAS, we can also simplify inside the parentheses. So for this one right here, I could say 3 times, 1 plus 6, using the substitution property, that's just 7. 3 times 7 is just 21. Another way is I could say, well, what's 3 times 1 plus 3 times 6? That would be 3 plus 18. They're going to get you the same answer every time. Personally, when they are using just numbers and no variables, meaning that you have like terms, I would just write inside the parentheses. I would simplify it if you can. So 4 plus 5 is just 5. 5 times 5 is 25. So this next part says using the distributive property, simplify without the use of a model. So that's kind of the whole goal that we were getting at here, is simplify without the use of a model. So 2 groups of 4x plus 3. I'm going to rewrite 2 times 4x, and then plus 2 times 3. The most common mistake that I see, even in 8th grade, is people forget to distribute this 2 to the second term. That's a really important step there. So 2 times 4x is 8x, and then 2 times 3 is 6. Because these are not like terms, one has a variable and one doesn't, I can't combine them. This next one, 21, 3 times x plus 3 times y. That's actually as far as I can simplify. So that's 3x plus 3y. So I would like you guys to try 21 and 23 on your own. That is the end of the lesson for today. I am going to give you guys a little bit of leeway because I know some people have power outages. Please just let me know if that was your case. But I will be collecting the notes, so make sure that you turn in the notes to this assignment on Google Classroom and that you have also answered that attendance question.